All right, kids, it's Mr. Worthen here. I hope you all had a wonderful break. Um, Happy to have you back and get learning again. I know this isn't the best or easiest, but it is what it is, so let's make the most of it. On day one, you guys were doing square roots and cube roots, but they were always, you don't need to write this down, by the way, they were always friendly ones, numbers that came out nicely. So the square root of 49, we said was 7 because 7 times 7 is 49. Well, essentially, all that meant was since I had two 7s, I was able to bring one outside. I should put it out there. And then there was nothing else inside, so there was no square root. I didn't need to write that because there was nothing left in here yesterday. But today, that's not going to be the case. So we're going to have to figure out how to simplify these when they are not pretty. And I hope you can see my calculator. I don't know if you specifically can, but I'm just going to go type one in here. I'll type this first one in here. And if you've got your calculator, go ahead and practice. Square root of 12 equals, it ends up being some crazy decimal, in case my calculator didn't show up. Ends up being some crazy decimal, and we don't like that in our math world. Now, in real life, if I was doing construction or laying tile or something like that, the decimal approximation about 3.5 or about 3.46 would be okay. The problem is, we being math nerds don't want approximations, we want exact answers. So we're not going to let you go straight to the calculator for this. However, the calculator can help us. I'll try to show you as we go. All right, so here we go. And again, if you did not get notes, they are on Teams, they're posted, you can print them off, or you can just write these on your own. Part of simplifying radicals, I just got to show you this rule with how radicals work. The square root of A times the square root of B is the same as the square root of A times B. So essentially, if you've got two square roots, you can just write them in one. Well, we can go either way with this. We can go from there to there, which we will do in a day or two. Or we can go from here to there, which I'm going to show you today, but we probably won't use it a ton. So here's how it works, and I'm kind of a weirdo for those of you who don't know me. But I talk about this as my jail. Like Gladiator was a movie. I don't know if you guys have seen it. Russell Crowe. And the way gladiators worked back in the day is they put two people in the ring and in the Colosseum, and they fought to the death, and one got to live. And we're going to kind of treat this the same way. And my advice to you, I'm going to show you two ways, but my advice will be this first way. Just go do the factorization of 12. So essentially, I'm going to create a factor tree. So when I look at 12, I got to break it into something. Now, Jojo might say 2 times 6. Paulina might say 4 times 3. It doesn't matter. I've got to go to the prime factorization. So I'm going to go 2 and 6. I've broken that down. Well, when I look at 2 and 6, I do not have, now stay with me, in my jail or my gladiator ring, I want to be fair. And when I say fair, I'm not going to let 6, some big dude, pick on a little dude in a fight. That's not fair. I want two dudes that are equal in size. So since I don't have two numbers that are equivalent in size, remember 2 7s on that first thing I showed you? I got to keep breaking them down. So can I break 2 down any further? No. There's nothing else that'll go into 2 other than 1, and that doesn't change it. But 6 can be 2 times 3. So now I have taken the number 12 and I have found the prime factors of 12. Why didn't I circle the 6? Because I broke 6 down further. So I don't need him. So in reality, this is the same as the square root of 2 times 3. I am just using those factors right there. Well, now when I look at this, I do see two numbers that are the same size, And now I can let them fight. And this is just a stupid analogy. If it works for you, great. If not, Ms. Powers has one about dating. I don't know. I'm sure she'll talk about it. But when I let them fight, one of them's going to die, and one of them gets to go free. Please notice where I drew that arrow. I let him out of my jail. He is no longer in the square root. He got to go free because he won. So now when I write this answer, this 2's gone. This 2 got set free, so he's outside of jail now. Did that 3 earn his freedom? Nope. He didn't fight in the Colosseum, so he has to stay in there. And now the simplified form of the square root of 12 is 2 square root 3. So we're going to get to the point where we have answers that'll say square root 12. You've always got to ask yourself, can I simplify that radical anymore? Is there any pairs or perfect squares in there that I could pull out? Okay, so stay with me. I'm going to come back and kind of show you another option here. I think what I just showed you is the easiest way to, it might be a little bit more tedious, it might be a little bit more work, but I would say that's the easiest way to go about it. Oh, by the way, I forgot to show you. If you have your calculator out, and I would practice this. Sorry, I'm trying to pull mine up again. And again, I hope mine's showing up. If it's not, you should be doing this on your own. When I typed in the square root of 12, I got this cray-cray decimal, 3.46410. I can check my answers by typing in 2 root 3. And if I have simplified this correctly, 2 times second root 3. So I've typed in 2 root 3. Now I included the times, but I don't need to. But I do want you to be aware that means 2 times the square root of 3. But when I hit that, and I'm hoping this is showing up again, sorry. Because those 2 decimals are exactly the same, that tells me I have simplified that radical appropriately. It might not tell me that I simplified it all the way, but at least I didn't make a mistake when I was simplifying. Sorry. Okay, so here's the other option here. And if you like this, use it. But not a lot of us are very awesome at our perfect square factors, the ones you guys practiced in day 1. And what I mean when I say that, I could have written, hey, is there a perfect square in 12? And I'm thinking of my perfect squares, that's this table that I made in day 1. And perfect squares were numbers like 25. Well, obviously 25 doesn't go into 12. 36 doesn't go into 12. But 4 was a perfect square. And 4 does go into 12. So using this rule that I showed you up here, you could have rewritten this as square root of 4 times square root of 3. And now the square root of 4 we should know is 2. The square root of 3 isn't pretty. It's an ugly, crazy decimal. So I would just leave him. That is another option to get the same exact answer. And if you're really good with your perfect square factors and division, great, go ahead. If you're not, go to prime factorization. Okay, so I look at 48. And I'm trying to think of things that go into 48. And those of you who are not very good with your division, this is going to be more time consuming for you. Does 2 go into it? Does 3 go into it? Does 4 go into it? Does 5 go into it? Does 6 go into it? And there are patterns with those numbers, but I know he's even, so I know 2 goes into it. Well, that's great, but if I can find bigger factors, larger numbers that go into it, it's going to make my simplification a little bit easier, less tedious. So when I think of 48, I think of 6 times 8. And it doesn't matter. You could do 2 and 24. I could do 4 and 12. You could do 3 and 16. All of those multiply to 48. But I don't have 2 people that are the same size, so I got to keep going. 6 is 2 times 3, and 8 is 2 times 4. And you guys probably get all excited because you see 2 2s, which is awesome. The problem is there are 2 other pairs in here that you might not see if you don't completely factor. I can't break down 3 anymore. Those are all prime numbers, but he is not a prime number. 4 is not prime. I could break him into 2 and 2, and now I'm going to rewrite just to clarify. 48 is really 2 times 3 times 2 times 2 times 2. And now let's go have our gladiator matches. When I look at this, I look for pairs of numbers. There are 2 2s. One will die, one will get to go out of jail. Well, these guys aren't right next to each other, but I don't care. It's all strung together with multiplication. So one will go bye-bye, and one will get set free. So now I have 2 2s out there. Well, what do I do with those 2 2s? Remember when I said it was 2 times the square root of 3? Anything I pull out of here, I'm going to be multiplying. Well, I still have this 3 inside who didn't get to battle, so he's going to stay in there. I'm still not done because that is a 2 and that is a 2. I can multiply 4 root 3. Now, why don't I multiply the 4 and the 3? Because one's in jail and one's out of jail. No good. Can't do that. And now 4 root 3 is my simplified version of the square root of 48. Next one. So now we're switching from square roots to cube roots. So all this means now is, instead of looking for 2 people to fight, I need 3 in order to get 1 free. In order to get 1 out of jail, I need triplets now instead of pairs. When I did square roots, I only needed pairs. When I do cube roots, I need triplets. So same process still. I'm going to start breaking this down. Actually, I'm going to keep breaking this down. No different. 54. I think of 6 times 9. Again, it's even. Could I have done 2 times 27? Sure. Could I have done 3 times 18? Sure. You got options. Well, you got to find something that goes into 54 evenly. Well, they're not the same, so I'm going to keep going further. 2 and 3. 9 breaks into 3 and 3. So when I go rewrite this guy, the cube root, don't forget that little 3 up there, you'll get marked wrong, is really 2 times 3 times 3 times 3. And be careful, because we're doing cube roots, I need all 3 of these to get 1 outside. So this 3, one of those 3's won. The other gun went bye-bye. And he got to come outside. Cube root, be careful. The 2 did not do anything, did not get out, so he stays. So the cube root of 54 is really, in simplified form, 3 cube root 2, or 3 times the cube root of 2. You'll hear it both ways, but this is the way you'll see it written. Okay, for those of you who are new to this, press pause on your video right now. It doesn't do you a lot of good just to copy down the answers. Practice a little bit and then make sure you're doing it right, so when you get to your homework, you have an idea of what you're doing instead of just writing down what I wrote. So I'm going to pause, write the answers. You guys practice A, B, and C. Okay, sorry, I moved my screen a little bit. So if you've done these correctly, the square root of 18 is the same as 3 root 2, or 3 times the square root of 2. The cube root of 40 should be the same as 2 cube root of 5. And the square root of 54 should be the same as 3 square root 6. I want to talk about C real quick. When we broke down 54, I ended up with 2, 3, 3, 3. Well, because it's a square root, I only need pairs of 3s. I have an extra 3 in here, which doesn't have somebody to fight with. These two were going to fight, one gone, one free. Well, these two got left in here. Since they're not the same size, they can't fight. And then I just multiply them. 2 times 3 is 6, and that is the simplified form. If you guys want to think about it, this is very similar. I mean, you'll find out radicals and fractions have a lot of similarities. And this is really kind of like reducing a fraction. There is a more simplified form, and we're going to require you to write it in that simplified form. Okay, a couple more, just same idea, except now we're throwing some variables in there. All right, I'm not scared. Well, I'm going to start with the 324. I have no clue what goes into 324. It's too big of a number for me, but I know it's even. So I'm just going to start with 2 and 162. I'm going to wait on these A's. I'll deal with them in a minute. 162, still too big for me. I don't know what goes into it. Maybe 8 does, maybe 16 does, maybe 5 shouldn't, but because it doesn't end in 5 or 0. But I'm just going to go 2 again and see what's going on, because 162 was even, so I know 2 can go into it. And that ends up being 81, and ooh, doggy, I'm recognizing 81. That's a good looking number right there. 81 is one of those perfect squares that I know is really 9 times 9. Now, stay with me. Could I break 9 and 9 down to 3 and 3? And 3 and 3? You could, but why not make life easier? Do you have 2 9s? Can you just let the big boys get after it? Sure. So the reality, this ends up being 2 times 2 times 9 times 9. Well, that takes care of my number, not done, but I've rewritten it. Well, I can just do the same thing with these a to the fifths. All this a to the fifth means, sorry, my phone's going off. I'm teaching, can I call you back? Okay, bye. Sorry. I can just take these a's and rewrite them. A times A times A times A times A. Sorry, I ran out of space there. 1, 2, 3, 4, 5. That's all a to the fifth means. Well, now I'm going to treat them exactly like I treat numbers. I have 2 2s. 1 dies, 1 set free. I have 2 9s. 1 die, 1 set free. A is the same as A, so they're the same size. 1 die, 1 set free. A is the same as A, 1 die, 1 set free. And now I got one lonely A who didn't get to fight in the Colosseum, so I got to leave him inside of his radical. Still not done. I got to put all this together nicely. 2 times 9 is 18. A times A is A squared. And then the square root of A just chilling back here at the end. And the simplified form of 324, the square root of 324 a to the fifth is really 18a squared root a. So the reality is all these variables, and you'll see a pattern here as we go, all these variables are doing is adding, I got to write out some a's or some x's or some y's or whatever. It's really not that tough because I don't have to really factor those guys. All right, I'm going to go to my next one. Let's go pink. I'm feeling sensitive. Still start with your 72. When I hear 72, I think of 9 times 8. 9 breaks into 3 and 3. 8 breaks into 2 and 4. I'm pausing because I'm not done. 4 can break into 2 and 2. So rewrite again. 3 times 3 times 2 times 2 times 2. And now I have 6 y's. 1, 2, 3, 4, 5, 6. And again, 6 y's from there. Looking for pairs since it's a square root still. 2 3s, 1 die, 1 set free. 2 2s, even though you got 3 of them, I only need pairs. 1 die, 1 set free. I've got a lonely, please notice, I've got more stuff to pull out. Can't do anything with that 2, but I don't want to lose him either. 2 y's, pull 1 out. 2 more y's, pull another out. 2 more y's, pull another out. And this lonely 2 is the only guy left in jail. So I leave him. Finish rewriting all this stuff out here. 3 times 2 is 6. Y times y times y isn't 3y. It's y to the third with the root 2 chilling at the end. Okay. One more for me, and then I'll turn you loose. I look at 50. I see 5 times 10. 5 cannot go any further, but 10 can. 5 and 2. That is as far as I can go. Those are my prime factors. Rewrite. 5 times 5 times 2 times x times x times x. 3 x's. Looking for pairs. 2 5s, 1 die, 1 set free. 2 x's, 1 die, 1 set free. I got a lonely 2 chilling inside and a lonely x chilling inside who couldn't come out. So leave them in there. I cannot do anything with those. That's already 5 times x. I can't multiply it and say it's 10 or whatever. I cannot multiply 5x and 2x. Some of you might be thinking, oh, they're like terms. No. When we multiply, I cannot multiply outsides with insides. You could multiply inside and inside, and you'll learn this tomorrow. You could multiply outside and outside, but I cannot take an outside and multiply it by an inside. Therefore, that's my final answer. Okay, again, please pause and do this on your own to see if you have a clue. I'll write the answer. Okay, I want to talk about a couple of these real quick. Again, I hope you tried. When you started breaking down 42, and I'm a little bit evil by doing this to you, you broke it down and you should have gotten 2 times 3 times 7. 6 times 7, 6 is 2 times 3, that's 42. There is nothing I can break any of these guys down further into. They're all prime. Well, we didn't have any pairs or anybody to fight. So, 2 possible answers you could see. Square root of 42 is as far as I can go. If I had the fraction 5/6, I can't go any further, I'm done. Or you might see the answer in multiple choice written as already simplified. It's as far as it can go. On E, breaking it down, I should have gotten a 3 and a 3 and a 2 and a 2 and a 2. And then 5 x's. Because it's a cube root, I'm looking for triplets. 2 comes out. 3 of the x's come out. Sorry, 1 of the x's comes out. Took me 3 to get 1, though. And I had 2 x's left and 2 3's left. Well, 3 times 3 is 9, and x times x is x squared. That's as far as we can go. In this last one, holy lots of 2's. 1, 2, 3, 4, 5, 6. Well, I'm looking for triplets. 1 2 comes out. Another 2 comes out. Lonely 3 left inside. And 2 times 2 is 4. Don't forget your little cube root. My video's already long, so I'm not going to do it. But anytime you have questions, if I make a mistake, which is a possibility, you need to make sure you circle that problem on your notes and ask your teacher when you guys Zoom. Likewise, I would like you to ask your teachers to show you how to do cube roots on the calculator when you Zoom. I just don't want to take up more time, and everybody's calculator is a little bit different. So, but it is a useful way to check your answer to make sure your decimals match up. Hope you all have a great day. Enjoy. Please start strong, start fast, stay on top of it, build yourself a base so that if something weird goes on, one little thing doesn't destroy your grade. Enjoy, kids.